All right, in this lecture, we're going to go into a little bit more detail about analyzing distributions. And more specifically, we're going to talk about percentiles, quartiles, z-scores, and so on. Um, Now, I put a video already in the playlist, and the author of this video does a really good job at explaining z-scores and percentiles, probably much better than I do. If you haven't watched the video yet, you can stop after 6 minutes. If you watch the entire video, you got some good information. But this should already give you a good precursor into z-scores and percentiles. So first, talking about percentiles, we want to understand briefly what they are. Imagine that you had a set of scores on an exam, like an SAT exam, and we had the average here in the middle. And let's say you scored in the 90th percentile. And this formula here tells you what location that 90th percentile is. And if this is the min and this is the max, we're going to find out that it's going to be about right here, right? So what that means is that at the 90th percentile, let's say that this is the 90th percentile here. Everything or everyone who scored less than that 90th percentile, or if you scored at the 90th percentile, you scored better than 90% of others that took the exam. But also, there's 10% of the people that took the exam that scored better than you, right? And the location we can calculate with this particular formula. Now, here's an example, and we're going to go through this shortly, but let me give you a little preview. Here we have the lowest value, and it's sorted in ascending order where this is the highest value. And basically, you take 85%, take the count of the number of values plus 1, and you multiply those, and then you get 11.05 out of 12. And that is the location of the 85th percentile. We'll go through that in a moment. Oh, I wanted to stay back here. And then we wanted to know what the value is at the 85th percentile. So here is an example of how all the percentiles are calculated. Okay. And we're going to show you in Excel how to get this done relatively quick. So let's go back to Excel. These are those home selling prices. Those are the 12 homes, and they're in no particular order right now. Okay, but we do know, the 85th percentile. If I were to sort these, actually, let's go ahead and do that. Let's just sort this column here. Okay, so we know that the 85th percentile should be somewhere near the bottom. And the way the formula worked, it was 0.85 times open parentheses, and we have to count the number of values. Right? And we have to take that count and add 1 to it. And I close off the parentheses and hit enter. And we can see that it's at 11.05, which is what the PowerPoint had said. And so that means that the 85th percentile exists somewhere around here. Okay. Now that's based on 12 values. Now, realistically, we would hope that the 85th percentile from the calculation standpoint is actually existing in that sequence. So how do we calculate that? Well, we're going to use a formula here. We're going to use percentile exclude, or EXC, and that excludes the median or the mean. And there's a reason for that mathematically. I'll let your statistics teacher deal with that. But basically, it becomes, well, it does make some changes with your percentile. But so for the purpose of this course, we're going to use percentile EXC. All right. So we're going to go ahead and put in the formula, select the array, and then the K value in the percentile is what percentile we want. Now this has to be less than 1, so 0.85 is what we want. And now we can see that the value is 305,912, and we can see that it really does exist between these two numbers, just a little bit over 298,000. Okay. So that was really convenient. That's really easy on how to do. Okay. So let's go back to our PowerPoint. Now we're going to look at quartiles. So going back to our normal distribution, there we go. And if we split it in half, we can easily say that this is the 50th percentile. Now, if we split the half in halves, now we have quarters. So everything, let me choose a different color here. Let's try blue. Everything from here to here will be the first quartile. Here to here will be the second quartile. Here to here will be the third, and here to here will be the fourth. Now, if you look here in the analysis, we're really looking for Q1, Q2, and Q3 because the variables of interest are really going to exist. I'll go back to blue, right here, here, and here. And the reason for that is because at this end is the minimum value of our data, and over here is the maximum value of our data. So if we knew the 50th percentile, we would have a good data point. By the way, this should equal the mean. And then the 25th percentile right here will give us the halfway between the minimum and the mean, or the 50th. And the 75th percentile will give us the halfway between the 50th and the max. Now, let me also make another point I don't want to make any confusion of, is that in a normal distribution, typically the lines for the 50th percentile and whatnot look pretty symmetric. However, if you have something that looks like this, your 50th percentile could be here, your 25th percentile could be here, and your 75th percentile could be way out there. Okay, so there's 1, 2, 3, and 4. And the reason is because this takes into account the number of occurrences that are in that particular range. All right, just to make that clear with what we're handling. Okay, so I'm not going to get into z-scores right now. That other video should have been able to handle that. What we want to know with z-scores, it's about the relative location of a value in a data set. It's a little bit different than a percentile, but because it's standardized, which means that you can kind of compare two different data sets and then it'll standardize between the few. All right, and here's a calculation for z-scores and able to calculate that. All right, let me go to Excel and I want to show you calculating the first quartile, second quartile, and the, excuse me, I said this should be the, yeah, and then this will be the third quartile. Okay. Okay, this is easy. This is quartile exclusion. Get your data set, comma, first quartile. Boom. All right. This is quartile exclusion, your array, comma, 2. And then the last one, quartile exclusion, your array, and 3. Oh, comma, 3. There we go. Now what we can see is that if we find out what the minimum is and the max, we'll be able to know our entire data set where all the quartiles is, or the range of all the quartiles. Okay. All right, we'll continue on with this in the next video.